Hi guys, hope all of us are doing fine. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In this particular discussion, I'm going to look at the concept of moments. But before we proceed, of course, I'm going to request our members to kindly subscribe, engage us in the comment section, and also check our description boxes for various links of other similar videos which I'm going to put there. So in this case, basically it's going to be a concept under statistics. And we're going to look at how we can treat this specific aspect of moments using the concept of a general variable that we had given for specific distribution. Now in this case, I'm going to use the variable of x, and let x be a specific variable that can be described in terms of particular values which we have given generally for x1, x2 to a value of xn. We can give the mean for this specific distribution by using this specific notation, and of course this is going to represent the concept of the mean. And we can as well describe the standard deviation of this particular set of distribution using this abbreviation for S. I've discussed, of course, about the concept of the mean and the standard deviation. And as I said, I'm going to put a link of these specific videos in our description box. And as well, I can give the particular value of course, of what we refer to as the variance, which of course we had said that this is going to represent the population variance given as such, and of course what we refer to as the sample variance given as such. So in this case, we're going to monitor the relationship that is going to be coming up from this concept of the moments from its particular definition. So given a particular variable x which can be described in terms of these specific values, we can define the rth moment about or the rth moment of this specific distribution by giving it as so this is going to be rth moment by giving it as x r. So this is going to be x bar raised to r given as such, and this is going to be given in terms of x r1 plus x2 r plus, so this is going to go on to a particular set of value of n, and that is going to be divided by the number of values of n given as such, and this is going to define the rth moment given as the rth moment of this specific variable given as r. And from this, of course, we can give this one as a representation of a summation of from this particular set of values for I is equivalent to 1 to n of x I raised to power r divided by n. So in this case, we have come across analogous formula, which of course are going to represent especially the arithmetic mean from our previous discussion. Now in this case, this is going to be, suppose the value for r is going to be, of course, given. Let's assume the value for r is equivalent to 1. This is going to represent the arithmetic mean of the specific set of raw data which we have come across in our particular discussion. So suppose we have a frequency distribution, of course, in this particular case, we can give the rth moment of that specific distribution using I is equivalent to 1 to k of a particular frequency given as that one divided by n given as such. So in this case, this is going to give us a particular moment of frequency distribution, and of course this is going to give us a particular moment for raw data given as such. So in case this particular aspect of r is equivalent to 1, therefore this is going to represent a simple arithmetic mean, as I said, and of course this can be given in terms of the arithmetic mean. So for the condition of r is equivalent to 1 in this formula, it's going to represent an arithmetic mean, and sometimes we are going to refer to this one as the first moment. So from this general formula, we can give a condition of r is equivalent to 1, and this is going to represent the arithmetic mean, or what we refer to as the first moment. So in this particular respect, then therefore we can develop different representations for various moments, perhaps using the various types of averages that we have come across for the, particularly the mean, and try to see what are some of its implications. So therefore we are going to look at the concept of the arith moment about the mean. So this is going to be arith moment about the mean, and try to see what are some of its implications. So generally we have said that we can represent a moment using that specific representation of the two formula that I've given. And of course, whenever we are talking about the arith moment about the mean, then therefore we're going to find the difference between these general variables, general set of values for the variables and the mean, whereby the arith moment about the mean is going to be given as m sub r, which is basically the summation from I is equivalent to 1 to m of values of the difference between this specific mean and a particular variable, and this is going to be given in terms of the power of r given as such, and this is going to be divided by the number of observations given as such. So we can give this formula as well in terms of n minus 1 over m, and of course that is going to be multiplied with the summation of I is equivalent to 1 to m of the particular values of this specific difference between the mean and the x value, and this is going to be divided by the values of n minus 1 given as such. So these are two different formats which we are going to represent this moment about the mean using this specific procedure, and of course that's going to be especially given for the case of raw data. So in case we have a frequency distribution, then therefore we can as well have a different variation of this particular formula, whereby we're going to have the moment about the mean given in terms of the summation of I is equivalent to 1 to k, whereby k, as we said, is the number of classes, and therefore we're going to have this one as x I minus x, the mean, the square of that one, and this is going to be divided by the value of n given as such. So we have developed the moment, the arith moment about the mean using these two specific formula, and I'd like us to be taking a keen interest of the relationship between this specific formula for the value of r, especially for the concept of population variance and the sample variance that we have discussed, and the concept of perhaps the standard deviation, which we have looked at in the different videos. Now this case, this of course is going to create a connection between the concept of moments and the various aspects of variance and deviation, which we have discussed. Of course, if we try to look at this specific case, especially for the moment, the arith moment about the mean for the frequency distribution, we're going to have this one basically giving us the concept of population variance, which we had discussed in our previous video given in this specific term. And therefore, if the condition, if r is equivalent to 2, so we had said that if r is equivalent to 1, then therefore for a moment that represented the arithmetic mean of the first moment. And in case r is equivalent to 2 for frequency distribution, then therefore this is going to represent what we refer to as population variance, which we had given in our first case. So this is going to be referred to as the second moment, or the second central moment, now that we have talked about the mean. And therefore we are going to see that this one can be given in this particular case for a population variance. Now we had said that we can develop a sample variance from the population variance by having the particular number of variables minus 1, and therefore if we try to look at this specific representation and assume that perhaps the difference between n minus 1 is basically a value that is going to be representing an approximate value of n, then we can have a variation of this specific formula, therefore giving us what we refer to as the sample variance in that particular case. Now, if I can perhaps try to look at a small reminder of what we have looked at, perhaps I can have this space. Kindly remember that this the arith moment about the mean that we are discussing. So I'm just going to have that space so that it can assist us try to create a connection between these different types of variance that I'm talking about. So from our previous discussion, basically that defined the concept of what we refer to as the population variance, and given it in terms of this specific representation, which of course implied 1 over n. And this, of course, gave us, or we can give this particular population variance of a frequency distribution so that we can have a comparison with this one. And of course, I defined this one as 1 over n, of course, the summation of values of product of frequency and, of course, this specific difference, whereby we had said, now for our population, of course, we had said that this is going to be represented by this, and it's going to be a square of that particular value. And in this case, I mentioned that, of course, the I is going to be ranging from 1 to a value of k for the number of classes. And therefore, we are going to look at this specific condition whereby I've said that if in this particular video, in this particular value for the concept of n minus 1 is roughly equivalent to n, we are going to have n over n equivalent to 1, and then we're going to have this one just represented as n. So for the value of r is equivalent to 2, then therefore we're going to have a square of this. Therefore, there's going to be an analogous formula to this specific description for the population variance given in that particular case. And this is going to be, of course, the second, what I refer to as the second central moment, which is going to be representing a population variance in case we have this particular condition. Now, I'd also talked about the concept of a sample variance, and in case we have this specific aspect of a sample variance, I can have this one given as a sample variance. And this one was given in terms of the square of s, and of course, which we had defined for a frequency distribution in terms of 1 over n minus 1, and then we had given that one as the summation of f1 into xi, this is fi into xi minus x. That's going to be the mean, the square of that one. So in case we are going to consider this specific value for the sample variance, and we're going to assume, as I said, that this particular value is equivalent to n, then we're going to have this specific second moment basically representing sample variance in that particular case. So that's going to be the relationship between this specific aspect of the moment and the two variances for population and sample. And of course, we're going to look at now the general case that we can use for representing the arith moment about n number apart from the mean, which I've discussed. So therefore, we shall look at the moment about n other number. So this is going to be the arith moment about n number, arbitrary number that I'm going to give in terms of a, and that of course is represented by the particular representation of mr. The arith moment about the number is given as the summation from I is equivalent to 1 to n, and of course that's going to be given as the difference between those specific values, of course, of a raised to power r, and we are going to have the whole of this divided by n given as such. So I decided that we can give this one in different variations of course, this particular summation, whereby we're going to have this one as n minus 1 all over n, and then we're going to have this one given in terms of the summation of x minus 1, or the summation from n is the summation from I is equivalent to 1 to n given as such, and of course this is going to be xi minus a all over n minus 1 given as such, and of course we had given this one as a general formula, and this is going to be the arith moment given as such. Now this was for a general case of raw data, and we had given a specific version for the frequency distribution, whereby we had considered this specific representation of the arith moment about a number, whereby we're going to have this one as a summation between 1 to x number of classes, and the product of frequency and the difference between those specific values and that particular number given as such, and that's going to be raised to power r given as such over n. So this is going to be for raw data and the frequency distribution of the earth moment about a number given as such. So in case we come across various aspects of the moments as we're going to go by different topics of our discussions, we're going to remember about the concept of the first and the second moment, or the earth, the first moment, perhaps the earth moment, central moment, and the first, of course, or the population variance relationship and sample variance relationship, and also the central, or the second central moment, which are given. And this is going to be the general case for representation of the moment, the earth moment about a number, which we have given in our last two statements of our discussion. So kindly check our description boxes for various links of other videos, and perhaps we're going to do one of the sample questions which is going to assist us understand better this aspect of the moments, the earth moments about a specific value A, or a particular an arbitrary value A, and other aspects like the mean, the standard, or the standard, or rather the population variance and the sample variance which I've mentioned. So that is it for now, guys. Bye, God bless you. Catch us in our next video.